Hello, 8th grade science. This is your second instructional video for the first week of Unit 3, and this kind of follows that second activity of the provocation. So yesterday we should have worked on your vocabulary. I think there's less words than there is normally too. So while we're kind of throwing a lot at you this week, I think there should be enough time still to get everything done. I don't even know, a page and a little bit. So I think you guys can do that. The provocation is also fairly short too, and I'll go through it and do that in the directions. The goal of the provocation is to learn about how organisms, living things really, how they've changed over time, and how you're going to do this is you're going to be looking at some ancient organisms and trying to figure out who their modern day relative is. For our success criteria, that I really want you to be able to describe using some evidence from either research articles, pictures, things like that, to support how the ancient and the modern are similar. So you're going to use some details in your guess or your explanation. And you also need to describe, using evidence again, how they're different. So how are they alike? How are they different? Using some pictures. I think there's some reading you're going to be doing, things like that. If you look at our lesson plan, there'll be bell work that'll be linked here. This video is called The Age of the Giant Insect. So way back in Earth's past, so not fairly recent, it was a while ago, insects used to be huge. There was a time where they were giant, and they kind of talk about how these bugs were giant, what the reasons were. I had to do a lot with the environment and things like that. We have another pear deck. This one's different than the one you did earlier. But this is on looking at, and I've always wondered this when I was a kid, so I'm hoping this kind of sparks your curiosity too. But we're looking at what's called divergent evolution. It's when two living things, they basically come up with the same solution to a problem, and so they look a lot alike, but they're not related closely at all. So like a really good example that I think is the first one on there is like a flying squirrel and a sugar glider. So those animals are actually really different, but when you look at them, they both have those flaps of skin, so they can kind of glide on the air, and they look a lot alike because they're fitting the same role or niche in their environment, but they live in different environments. So it's just interesting to look at when we talk about evolution, because even though animals have changed, over time quite a bit, some of these animals have figured out the same solutions to these problems. In this case, getting from tree to tree. I do want to go over the notes. So there are some notes that I want you to take. These kind of follow the vocab words you guys would have talked about. So if you look here, we have in the very middle is the theory of evolution. And so that's just a process when species change over time as a result of changes to their genes, that genetic information, and that then gets passed on to the next generation. That's really all what evolution is all about. Okay? Now, if we want to break this apart, we kind of already know what a species is. If I look at the teacher notes here, which is what I'm going to pull up, we've talked about what a species is way back in Unit 2. But to clarify, a species is organisms that share similar traits or genes and can reproduce successfully. And so you could list any examples: horses, bats, squirrels, whatever example you want, you could list for species. Now, when we talk about a generation, this is probably going to be a new term. So a generation is just that next step down in the family tree. So for example, parents and offspring are two different generations. So your parents are one generation, you would be a generation, your grandparents are a different generation because they're a step above your parents. Your great-grandparents are a step above that. Those are all different generations. And the real key thing is, when we're talking about evolution, is that those genes, those changes to genetics, they have to be able to be passed down from one generation to the next, from your grandparents to your parents to you, for example. Hopefully that kind of clicks. That's why we have to really know those two things. And then the bottom part's really what we're going to be looking at the rest of this week. How do we organize all these different species, all these different things, living things that all kind of are changing, millions of years at a time. And so we use these things, these different tools, and we listed a couple of them here. Cladograms, phylogenetic tree, they're essentially the same thing. You can see an example here to the right, and then a dichotomous key is a little bit different. And really, they're just similar ways to classify and organize information, mainly used to classify species and to figure out who's related to who. So it's almost like a family tree, but of every living thing. That's really what these cladograms, phylogenetic trees are. They show, that humans are related to monkeys are related to lemurs, that kind of stuff. It kind of shows, based on characteristics, how animals have changed over time in a lot of ways. And this is really what we're going to be digging in this whole unit, but really especially this week on how to use these trees and cladograms and dichotomous keys as a tool to figure out who is related to whom. So those are the notes. I'm going to go through how to do the assignment in the directions, so make sure to watch that. Have a good day. Bye.